Have you ever looked at a bridge, a big steel and concrete, thousands of ton bridge, and wondered, why does it look like it's made of triangles?
Nah, I would never wonder that.
Okay, well, even if you haven't, once you notice it, you just can't unsee it. I mean, look at these triangles.
Yeah, that's a lot of triangles.
Whether it's an old wooden railway, a steel truss bridge from the 1900s, or a modern megastructure spanning miles across the bay, triangles are everywhere.
And today, we're going to be diving into why triangles are the strongest and most common shape used in bridges, and how this one simple object basically allowed human civilization to defy gravity, weight, and even the forces of nature.
You see, before we talk triangles, we need to talk about the problem. A bridge has one job, to carry weight across a space without collapsing. That sounds simple enough, but physics would disagree with you. See, bridges face three major enemies.
Compression, forces trying to push down on the object. Tension, trying to pull things apart. And then shear and bending, which is twisting, bending, and sideways forces that try and break the structure.
And here's the thing. When cars drive across, when wind pushes on the sides, when temperature changes expanding the materials, the bridge is constantly fighting stress. And here's the twist. Materials like wood, stone, steel, or even concrete aren't perfect. Some handle compression well, but snap in tension. And some bend, some crack, and some even twist. So engineers needed a shape that could distribute weight evenly, resist bending, stay rigid, and not change shape under force. However, there is one shape that can solve all of these problems. A shape so powerful it can withstand any challenge. It's the triangle. You see, triangles are the strongest geometric shape for one simple reason. They're the only polygon that cannot change shape without changing the length of its sides.
Now let's break down exactly what that means.
You see, imagine a square. If you push down on the side, say this side, it becomes more of a diamond shape. This is not what we want, because then the structure will collapse. Now you imagine a triangle. Push on it and, well, nothing's gonna happen. It's gonna stay that same triangles, and it won't change shape unless you literally break each beam. You see, this is because triangles have fixed angles, sides that support each other, and weight distributed across all sides. Also, when looking at a triangle and the weight distribution, one side will always experience the compression. Therefore, another side will always experience the tension. And the third side is always going to be used to stabilize the whole structure.
This balance spreads the force through every part of the triangle. The shape wants to stay solid, so it'll naturally resist deformation.
So to sum that all up, a triangle is basically the superhero of structural engineering. So then you may be asking, how exactly do engineers use triangles in these bridges?
Now, I don't really know who's asking these questions.
I'm going to answer it anyway. There are a few major ways triangles show up. Number 1, the truss bridge. These are the bridges where the metal beams are arranged in repeating triangle patterns. Why triangles, you may ask? Because a truss is basically a massive network of triangles working together. Each triangle carries some of the load, transfers force to the next triangle, prevents bending, and adds rigidity. This allows the bridge to hold way more weight than a flat beam ever could. The entire structure is like one giant team of triangles passing the stress from one to another. When talking about triangular bridges, we can't forget the number 2 on our list, the suspension and cabled stayed bridges. Even when the structure doesn't look triangular, believe me, there are triangles hiding everywhere. When you look at the cable stayed bridge, look at these 3 parts. The deck, which is the part you drive on for those who don't know, is supported by cables. Those cables form triangular patterns with the towers. These triangles stabilize the deck and keep tension forces spreading evenly. Without that triangular layout, the cables would swing and flex like spaghetti. And we can't talk about triangular bridges without talking about my personal favorite, the arc bridge. See, arc bridges use triangular action. These arches don't look triangular, but the way they work is very similar. The curved shape transfers force sideways, turning downward pressure into compression. That compression then spreads out like an invisible chain of tiny triangles. And engineers often reinforce arc bridges with internal triangular framing. Now let's go more scientific. But don't worry, we're going to keep it simple with this one. When a force hits a triangle, it splits into tension and compression. Here's what that means. The top beam might be pushed together, and that's compression. The bottom beam might be pulled apart, and that causes the tension. The diagonal beam stabilizes the shape and transfers the forces. This is called triangulation. Now, a common question people ask is, why don't engineers use circles or hexagons or something more advanced looking?
Actually, I am wondering that.
Well, that's great, because even if you didn't ask, I'd be telling you anyway. So here's the truth. Other shapes either don't stay rigid, or they require way more material to resist force. See, you look at squares and triangles? They deform easily. You'd need to cross braces, which turn them into triangles anyway. Hexagons? Fantastic for bees. Terrible for bridges. They twist under stress. Circles? It's an absolutely beautiful shape, but extremely inefficient structurally when used in large frameworks. Triangles hit the perfect balance. They're simple, rigid, material efficient, handles both compression and tension. They're easy to repeat in large patterns, and predictable under stress. Now let's go back to our original question. Why are triangles the strongest and most common shape in bridges? This is because triangles are the only shape that stay rigid under force, spread load evenly, resist deformation, balance tension and compression, use material efficiently, scale up into megastructure, and can withstand wind, earthquakes, and constant vibration. Triangles aren't just a good shape, they're the perfect shape for structural engineering. So the next time you drive over a bridge, look at the beams, the supports, the cables, or even the shadows beneath the deck. You'll see triangles, silent, invisible guardians holding everything together. And that's why triangles have been used for centuries, why they're used today, and why they'll continue supporting our world for hundreds of years to come.
Thank you guys so much for watching, and I will see you whenever I decide to upload next.